So, today we will discuss asymptote. So, what is let me first define what I mean by vertical asymptote. The line x is equal to a is said to be a vertical asymptote if limit x tends to a f of x, this is equal to either plus infinity or minus negative infinity. This is plus or minus infinity. For example, let us say x equal to 0 is a vertical asymptote of the curve 1 by x. Now, if you take y is equal to tan x, then x equal to pi by 2, this is then tan graph will go like this, and also x equal to minus pi by 2, tan will look like between minus pi by 2 to pi by 2. So, x equal to plus or minus pi by 2 are going to be the vertical asymptote for the curve y equal to tan x. So, now we will define horizontal asymptote. We say that a line y is equal to a is said to be a horizontal asymptote if limit f of x, x tends to plus or minus infinity, does not matter, is equal to a. That means, if I let us look at y is equal to 1 by 1 plus x square, or even y equal to 1 by x, if we are looking like in the earlier case y equal to 1 by x or y equal to 1 by x square, then when for 1 by x, when x goes to infinity, this y will go to 0. So, this will be like this. This is going to be the horizontal asymptote. Y equal to 0 is going to be the horizontal asymptote here. Similarly, limit 1 by 1 plus x square, x goes to plus or minus infinity, this is equal to 0. So, for this also, this line y equal to 0, it is going to be the horizontal asymptote. Now, what does it say? So, this is y equal to a, can suppose this is a. So, this is if my graph is something like this, then this is going to be the horizontal asymptote. So, the line y equal to a is horizontal asymptote if f of x minus of a, if I take this limit x goes to plus or minus infinity, this is equal to 0, that is what we are saying. So, there is nothing holy about the line y equal to a, we can consider this phenomena for some other line. So, which a slanting line too, may not be parallel to the x axis. So, in that case we have a notion called slant or oblique asymptote. So, a line y equal to any line m x plus c is said to be a slant asymptote if I look at for horizontal asymptote I was looking at f of x minus of y constant a, here I will look at m x plus c. Now, I take the limit x goes to infinity. Now, if this is equal to 0, then we say that this line is going to be a slant asymptote for f. Example, let us take y is equal to x cube by x square plus 1. Okay, so, this I can write it actually as x cube plus x minus of x by x square plus 1, which is equal to x minus x by x square plus 1. Therefore, this is our let us say f of x. Then f of x minus of x is equal to minus x by x square plus 1, which goes to 0 as x goes to infinity. Therefore, so y equal to x is a slant asymptote for f. For this curve, this is going to be a slant asymptote. Okay, so, as a matter of fact, if we are given with a rational function, suppose f of x is equal to p x by q x, where p and q are polynomial and q x is not 0 in order to define this. Now, if degree of p x is equal to 1 plus degree of q x, then f is going to have, then the curve actually defined by the graph of this So, here there is abuse of notation, f means what we are talking about, the curve graph of f, the curve x f x. Okay, so, now we are all set to do some qualitative curve tracing. So, what we need to do for curve tracing? So, we will follow this guideline. First, figure out the domain of the function, because you want to draw the graph x f x. Now, first domain of f, domain of the function. Then we will find the intercept. Intercept means when it is crossing the x axis, that means when f of x equal to 0, or what is the when it is crossing the y axis means x is 0 f of 0. So, that is what that means f of 0 and x As we have seen earlier also that this may be difficult. Okay, so at least we know some value f of 0 what is the value, and if we can find out when it is crossing x axis, that is fine. Then the third is symmetry. If that means either even or odd, then that will save us lot of labor, because we will only concentrate on one axis. If it is even, we will repeat it on the negative axis. If it is odd, then the negative of what we have drawn in the positive axis. Now we will check asymptote. Then there will be 3, that means we will need to check whether there exists vertical, horizontal and slant. Then we have, if our function is differentiable, then we know that we can determine that when the function is increasing or decreasing by the first derivative test. So, intervals okay. Then local maximum or local minimum. We will determine whether there is some local maximum or local minimum, accordingly we will vote. And then of concavity. We will try to determine in which interval this is concave up or concave down. Then finally, we will sketch the curve. Okay, so let us do a concrete example. Let us start with f of x equal to x square by square root of x plus 1. Now, what is the domain? The domain of this function is x greater than minus of 1, that is minus 1 infinity. What are the intercept? Now, f of 0 is equal to 0. Now, if in this case if f of x equal to 0, this will imply that x square is equal to 0, that means x is equal to 0. And then third is that symmetry. So, no symmetry. Fourth, we need to check asymptote. So, vertical asymptote. So, limit x goes to minus of 1 plus of f of x, this is equal to infinity. Therefore, so x is equal to minus 1 is vertical asymptote. Okay. Now, there is no slant asymptote, no slant, and limit x goes to infinity, this goes to infinity, it is not going to a finite value. So, there is no horizontal no horizontal asymptote. X goes to infinity. Okay. Now, interval of increasing and decreasing, for that this is a differentiable function. So, let us calculate f prime of x. F prime of x is going to be x plus 1, and then this is 2 x into square root of x plus 1, and then minus of x square, then this is 1 by 2 square root of x plus 1. So, if we so this is going to be 2 x x plus 1 minus rather 4 x minus of x square divided by 2 x plus 1 to the power 3 upon 2. Further simplifying it, what we are going to get is that this is 3 x square plus 4 x divided by 2 x plus 1 to the power 3 by 2. Now, we would like to get if x, the denominator is always positive. So, 3 x square plus 4 x is positive if and only if. Now, if suppose x is positive, then definitely this is positive. So, the further simplification will give that this is x, this is 3 x plus 4 divided by 2 into x plus 1 3 by 2. As you can see that if x is positive, then f prime of x is positive. So, f is increasing on 0 infinity. Now, if x is negative, then what you are going to get, this 3 x plus 4 is always positive, because x is greater than minus of 1. Now, x is negative, therefore, this entire thing is negative. So, f prime of x is negative. So, f decreases on minus 1 0. Now, we will find the local maximum or local minimum of this function. So, what is the critical point? F prime of x is equal to 0 if x is equal to f prime of x is equal to 0 if x is equal to 0 or minus 4 by 3, but minus 4 by 3 is not in the domain, So, what we need to actually find out at x equal to 0. So, now f is decreasing on the negative side for negative x and increasing on the positive x. Therefore, what we can say about x equal to 0, that is going to be a local minimum. So, x equal to 0 local minimum. In fact, because this is a positive non-negative function. So, this is going to be actually an absolute minimum in this case nevertheless. Now, we need to determine the concavity, because what we know is that if I have a graph, then f of 0 is 0, this is going to be the vertical asymptote, this is minus of 1. Now, on this side it is decreasing, on this side it is increasing, but we do not know either this way it is going to be or this way it is going to be or this is going to be, we do not have any idea unless and until we study the concavity. So, let us to do that, of course, we need to calculate f double prime of x. If we calculate f double prime of x, then you can do it on your own. It is a simple calculation which is going to give us 3 x square plus 8 x plus 8 divided by 4 into x plus 1 to the power 5 upon 2. And then f double prime of x is positive for x belongs to minus 1 infinity. Therefore, f is concave up. So, every time this is going to be concave up. So, therefore, now qualitative picture of this, that this is going to be 0 here, then on this side increasing, on this side decreasing, and this is concave up. So, this is what is going to be x square by square root of x plus 1. Okay, so we can draw some other curve, like for example, we have started with this f of x, this is equal to x cube by x square plus 1. Here what we have seen is that the domain is R, intercept is x equal to 0 is x intercept and y intercept, and the symmetry, this is odd function f of minus of x is equal to minus of f of x. So, you are only interested on the positive part, and the asymptote what we have, there is no vertical asymptote and there is no horizontal asymptote, because if you take x goes to infinity, then this is going to infinity. So, no vertical and no horizontal asymptote, but we have observed that there is a slant asymptote. Y equal to x. Now, you need to get the interval for increasing or decreasing, you need to calculate f prime. If you calculate, you are going to get that this is x square plus 3 divided by x square plus 1 whole square. So, this is always greater than 0, greater or equal to 0, then increasing. And there is no change of sign is happening to f prime. So, even at the point f prime equal to 0, that means x equal to 0, it is not changing sign. So, therefore, no local maximum or minimum, no local max or min. So, now for the concavity, you compute f double prime of x, which is going to be 2 x 3 minus of x square divided by x square plus 1 whole to the power 3. Now, f double prime of x equal to 0, that is what one would like to find out. This is when x equal to 0 or plus or minus square root of 3. Now, you check with x less than minus of 3, you will get that f double prime is positive, f prime increasing, therefore, convex upward. Now, 0 minus 3 less than x less than 0, f double prime is negative, f prime decreasing, convex downward. Then you have got between 0 and square root of 3, f double prime is positive, f prime increasing, then convex up, concave up. Now, if x is greater than square root of 3, this is f double prime is negative, this is concave downward. So, now you are all set to draw the graph. So, this is you have a slant asymptote like this. Now, you have point of inflection points are minus square root of 3 and then plus square root of 3. Then at 0 this is also. So, now this is 0 0. Now, square root of 3 you will calculate the point which has to pass through is here square root of 3, then 3 by 4 square root of 3, and here this point will be minus square root of 3 f of minus square root of 3, it is going to be minus 3 by 4 square root of 3. So, these are the point of inflection. Now, on this greater than 3, this is concave downward and this is going to be this. And from here minus 3 to 0, this is concave upward, and from 0 to minus square root of 3 to 0, this is convex downward, and from less than minus 3 minus infinity to this is. So, this is what is going to be the graph of this. Okay, thank you. We will see some more applications of differentiation in the next lecture. Thanks.